Okay, continuing on with this last free fall question, part C asks for its velocity as it strikes, well, as I catch it, the velocity just before I catch it, actually. So what is Vy? And that would be Vy, that would be at when t equals 2.9 seconds and when delta y is equal to 0 again. Well, there's a couple ways to do this. V equals AY, this is AY times t plus V sub 0 y. So that's negative 9.8 times 2.9, or it's actually 2.857, plus 14. And when you put that into your calculator, it's negative 9.8 times 2.857 plus 14. It comes out to be, lo and behold, negative 14 meters per second. And remember, I said that's one of the things I wanted to prove to you. That's the same speed as that. It's just in the opposite direction because it's going down. As I said, the trip up and the trip down are mirror images of each other. So it has to be the same speed to be the mirror image. It will always have the same speed at the same position. If it's going up, it'll be positive velocity. If it's going down, it'll be negative velocity. Okay. The other way to do this, of course, would be to just put it into here. All right. V squared equals V sub 0 squared, which is 14 squared, plus 0, because that's 0. And so the square root of this is plus or minus the square root of 14 squared. And it's the negative answer because it's on the way down. So, yeah, it has to be. All right. This next part. This is part D. What is its velocity as at a height of 6 meters? So what is its velocity when delta y equals 6 meters? Well, there are two answers. One on the way up and one on the way down. One will be positive, one will be negative. I know it passes through 6 meters because it goes all the way up to 10 meters. We already did that, part B. I'm going to use this equation. Vy squared equals V sub 0 y squared plus 2a times delta y. Again, delta y is not equal to 0 anymore. I want to know its velocity when it's 6 meters above where I threw it. And again, that happens twice, as it's on its way up and it's on its way down. Okay, so this is going to be plus and minus, because it does it on the way up and the way down. They're both valid. They're both correct. 14 squared plus 2 times negative 9.8 times 6. And the answer is plus and minus 8.9 meters per second. Don't forget the plus and the minus. Don't forget the plus and the minus. This isn't the only way to do this. I just find it to be the fastest way to do it. The next part, let's find the time. I'll usually phrase this something like, how much time elapses or when does it pass through the 6 meter point. Again, it happens twice. Do you have to write down both? Yeah, there are two answers to it. And you actually know there are two answers to it because this is a quadratic. Okay? And you know there are two answers for the quadratic, all right? So the time is squared. There are two answers for it. Well, there are two ways to do it, and I'm going to do it the easier way. You can put it into the quadratic formula if you want to, all right? Delta y equals V sub 0 y times t plus 1/2 AYT squared. So that would be 6 equals 14t minus 1/2 of negative 9.8. Minus, that's the negative. Half of 9.8 is 4.9 t squared. Again, this is half of negative 9.8. You have to put that equal to 0 in order to plug it into the quadratic formula, and then get 2 roots. You can do that. If you know how to use the solver on your calculator, that's what I do. Anyhow, if we want to avoid that, we can just use this equation twice. That's what I'm going to do. So I'm going to use this equation. Let's see here. The first time, on the way up, it's positive 8.9 on the way up. That's negative 9.8 t plus the initial velocity of 14. Solve for t. And that's going to be, what? 8.9 minus 14 all over negative 9.8. And that comes out to be 0.53 seconds. In other words, it's 6 meters high above my hand when I throw it upwards. It leaves my hand, and in just over half a second, it's 6 meters up. And the other time, let's solve that one more time using the same equation. It's on its way down, passing through the same spot. Now it's on its way down, so that's negative 8.9, not positive, but negative 8.9, equals acceleration is negative 9.8. Notice it's the same here, negative 9.8 times t. It still has the same initial velocity. It started out at 14 meters per second. Look at the similarities here. Only thing that's different between that equation and that equation is this negative sign. Otherwise, that's the same as that. That's the same as that. And that's the same as that. The only difference is this one negative sign because it's traveling downward now. Okay, so we solve for t. That's negative 8.9, negative right here. Subtract the 14 to the other side, so minus 14, just like before, all over negative 9.8. And I get 2.3 seconds. So it passes through the 6 meter position twice. After half a second, 0.53 seconds has elapsed, and then after 2.3 seconds has elapsed. And then it comes further down and catch it. Okay. Well, that was fun.